All right, so as our next talk, we're going to dive into polymorphic interfaces in KCP. And our speakers are Nelo, who's a development expert for SAP, and Robert, who's a software engineer for Clyso. But fun fact, he used to be at CERN. I called him just now an ex-CERN employee. He said he's not an ex-CERN employee, he's a previous CERN employee. So pass by, say hi. Right, the floor is yours.
Yeah, thank you very much. So today we want to talk about polymorphic interfaces in KCP, the three vendor problem. Before we go into the details of the talk, we want to talk about our sponsors, because all of our work that we do in KCP, API Sync Agent, Kubebind, and multi-cluster runtime is sponsored as part of the platform mesh, which belongs to the Neo-Nephros Foundation. The platform mesh defines an environment that allows service providers to offer services of any kind and service consumers to discover those services and their capabilities, order services, and control their lifecycle. That means you go from that you create a deployment. When you order a service, you just order a service by creating a Kubernetes resource. The Neo-Nephros Foundation has a big family, all great projects, so please have a look at them. They are all great, doing great work. To our talk, we first want to talk a bit about the problem description of what are polymorphic interfaces and why, what kind of problems do we want to solve with these. Then we'll jump into a service with a single provider, something that is possible with KCP today. Then we want to talk about how we want to implement a service with a single provider and multiple implementations backing this service. Then jump into how to possibly implement multiple providers serving the same service API. Then we have a little demo prepared where we show what is already possible with KCP today, and then we are wrapping it up. So, problem description, the three vendor problem. If you know the book, the three body problem, or the problem from physics, you know that there is no unique, no perfect solution that is always applicable. And we also don't claim that we have a perfect solution for every problem that you will meet, but we do want to give you the primitives and the technology so that you can solve your personal three-body problem. So, polymorphism. Thinking back to Programming 101, when you learned about interfaces, you will have some kind of request where you put in certain parameters, you pass them to someone else, and then you will just get an expected response back. So far, so simple. You don't really care what happens in between. You don't really care who really answers the request. You just give a specific request and you get a specific response out. And the easiest or most ubiquitous example for that is certificates. Because when you want a certificate, you don't want a certificate. You don't care who signs it. You don't care how it is signed, if it's coming from an appliance or cert manager or OpenSSL or. You just want your certificate to be signed. And everything else doesn't really matter. Some of the solutions for this are, of course, Cert Manager, which is great. Then every larger organization has at least one CA tree where you can get certificates signed, and you need to choose these depending on where your application is deployed and depending on what the use case for your certificate is. Some other uses are organizational limitations. If you have an interface for virtual machines, you want to apply restrictions based on who is ordering a virtual machine. Your web presence team is allowed and maybe even required to deploy to both cloud compute and your data centers. But your accounting, you want to keep the control of your data, so you only want to deploy the virtual machines for your accounting team on your own data center. Or execution environments. When you order a VM, you don't really care most of the time what the architecture is. So you just say, here's a VM, and then the compute team just takes care of it. Maybe you will later say, okay, now I need a ARM64 VM, and it's the same payload, it's just one property changed, but it's still the same API, backed by a different provider. Then load balancing, same applies. You just route the request to a provider depending on availability, capacity, and the request. Then legislative requirements. If you have a service that you deploy all over the world, that you sell all over the world, you will run into problems of where you can store specific data. So for example, if we are in the EU, we have the GDPR, so you maybe only want to store data from your EU customers in EU data centers. And for other customers, depending on their legislative requirements, wherever they need the data stored. Then in API marketplace, you have, for example, an internal development platform where you have a set of standard APIs that you want to define, like Postgres, Kubernetes, virtual machines, object storage, and then you get providers in. These providers can be internal teams. This can be external providers that you pay to offer the service for you, or just wrappers for cloud services that you define. And then you have consumers that are coming in, maybe external consumers like customers or your own internal teams. And they just order any of these standard APIs, and any of the providers provides them depending on where the capacity is available. Maybe you could also just do an overflow to cloud storage or cloud capacity depending on what is available. One of my favorite examples is CI/CD. When you define generic APIs, you can make your CI/CD a lot easier because you just request a certificate, and within your local deployment, you just have cert manager and use something like Crow to satisfy this API. And then in production, you have whatever provider satisfies the interface for that environment, just serves that request. And with that, I will give over to Robert.
Thank you. So we've seen where we can find polymorphism when building platforms, and the rest of this talk will talk about how we can build our own with KCP. So this is a little intro to KCP as a project. So what is it? On the project's homepage, there are a bunch of little definitions of the project, and you can see them on the slide. And if we take one of the shorter ones, framework for building platforms, we can try to dissect it a bit and find out what it really is. So let's consider for a second that this rectangle represents a platform. And on a platform, we can share services between different users, between different teams. And when sharing a service, we usually do it at least between two parties. One that gives out the service, the provider, and the one that consumes it, the consumer. So we have providers and consumers, and those are just two of the many personas we can find on a platform. And KCP basically helps us model this kind of relationship where different personas talk to each other through interfaces and APIs, and the language of that communication is KRM, the Kubernetes resource model. So the thing that you use every single day if you work with Kubernetes. Next, a platform doesn't really have an opinion about how the services it hosts go about their business. It doesn't really care about how they work. You can think of running a service just as one of the services that the platform provides, the compute service, for example. And KCP abstracts this away, and that's why it doesn't really care about containers, pods, workloads in general. When building a platform, think rather in terms of APIs and personas and how those interact with each other. And in this context, containers are just an implementation detail. And lastly, KCP is not a replacement to Kubernetes. First, because those two serve different use cases. Kubernetes is a container orchestrator. KCP is more of an API hub. And secondly, KCP is also a normal application that you can deploy in your Kubernetes cluster. And we offer a Helm chart, an operator, and you can check it out yourself. Cool, so with that out of the way, how do we actually use this thing? When talking to a KCP instance, we do so through something called a workspace. It's isolated, self-sufficient little slice of a Kubernetes API server. It even has its own URL address. You can see it down here. And you talk to it like you would with any Kubernetes endpoint, with some client like kubectl. We can have more of those workspaces in an instance, and they are completely isolated. Your CRDs, namespaces, in fact, all resources are contained within their workspace, and they don't see each other. There is like a line that separates those two. They can be laid out flat like this, or structured in a hierarchy, and you can walk this hierarchy and visit different workspaces, similar to how you would walk a file system, for example. And we actually offer kubectl crew plugin for this. Additionally, KCP supports splitting into shards, so you get horizontal scaling, and like that, you can then implement regions. So that's cool and all, but what useful work can we actually do if it's all isolated? So we've mentioned personas and services and sharing them. So in the next example, we are going to do just that. So let's have two workspaces, provider and consumer. In the provider workspace, we'll create something called an API export. And it's a built-in type in KCP, and it allows you to export resources, essentially. In this case, the resource we are exporting is simply called a service, but you can export anything, really, that you can write a CRD for. So this is just a placeholder, but anything CR-able resource you can put there. And then in consumer, now in the role of a consumer, you can create an API binding. This is also a built-in KCP type that allows you to bind to an API export of your service provider. And by doing that, you get that service available in your workspace, and you can work with it like you would with any other CRD-based resource. That means, like creating, deleting, updating, whatever. Now, back to being a provider, what more can you do? How can you support your consumers that are using your service that you are exporting? Well, there is this thing called a virtual workspace that you as a provider own and is linked to your API export. And using that, you can observe all your consumers who are binding to your export. So it looks like this. Similar to a normal workspace, the virtual workspace is also like a Kubernetes API server endpoint. So you get a dedicated URL, and you actually can observe who are your consumers and what objects of the resource that you have exported they are creating. And that way, since you have the URL address of that part of the kube API server, you can pass it to your kube config and then pass it to your operator. And just like that, we have actually just built a fully functional single provider service. We can create two consumers, and if we were to look at this setup from the viewpoint of the virtual workspace, we would see both of them now, and the operator would be able to reconcile them. So this is it, really, for the basics with KCP. We haven't covered a lot that exports and bindings can do, but the key takeaway really is that this is how you can easily share Kubernetes APIs between different tenants on a platform. And if you split them into different workspaces, you get isolation, but also something that really feels like a true provider-consumer relationship. And lastly, the operators that you use today will work with KCP out of the box. You will need to deploy a small sync agent in your provider cluster. This you will see later in the demo. But other than that, there are no code changes needed. So we are moving on to the first instance of polymorphic interfaces. And this is service with a single provider and multiple implementations. So if this sounds weird, it's really not. This is something you deal with every day if you work with storage in Kubernetes. So as an example, we see a user who is targeting some storage class from within their PVC, and that storage class then refers to some CSI driver, which is the actual backend specific implementation for that kind of storage. And what's important from the perspective of interfaces is that all that you care about as a user is this PVC, and all the rest of the stuff that is storage specific, you don't care about, thanks to this intermediate type, this storage class that can do the referring for you. We can imagine it similar to some generic API that has many different implementations, and if you were to program this in some sort of programming language, you would use like function overloading or something like that. So this is a really super useful pattern, and in KCP we want to give the engineers a tool to express this way of working with a service that has many different backends on their side, and expose this sort of workflow also onto the platform. And to show you better what I mean, going back to the storage example, if this part in yellow is running on the provider's cluster, the storage classes, the storage backends, then this part is what we need to expose and let be discoverable by the users, by the consumers on your platform. And this is so that they can refer to it when they create the final consumable resource on their side. So the left half, left 2/3 of this diagram are to be left on the platform, and then this part is to live on the provider side. So how do we actually do that? So we already know that API exports and bindings are there to share APIs, but you cannot really export objects of a resource. So KCP gives you, there is a built-in type in KCP that can actually do that. It's called cached resource. And it makes objects sort of exportable in a read-only way. So if you, as a provider, had some certificate service that has different types of certificates that you want to let your consumers know what they are, you can reference this cached resource in the API export, and then just like that, the consumer actually gets the individual objects that they can reference in their claims, for example. And a couple of more concrete examples, we could have instance flavors if you are creating some sort of VM as a service offering on your platform, or storage topology classes if you were to do some storage service and so on. Now, moving on to service with multiple providers. Nelo already shown us the individual use cases where we can find this sort of setup where you have different providers for a single API. And in this part, we'll try to see how we can model that kind of relationship in KCP. And also keep in mind that this is the actual three-vendor problem. This is not to be solved by KCP alone, but it does give you the primitives to get you started and on which you can then build your platform. So let's have an exercise. So the goal is to create a multi-provider certificate service. Since we haven't seen any other solution up until now, let's just try to do what we saw before and create this service as a single provider, as a single backed service, and then add more providers later on. So this works as it stands up until the very moment you add the second provider. now the consumer actually sees two kinds of certificates they would have to talk to and create create objects for, and this is absolutely not what we want. And this is the hard part. As a platform owner, it is your responsibility to provide some sort of common interface for this multi-provider service. It doesn't have to be like company-invented interface. You can, of course, use some actual standard for that sort of a resource and put it in your API export. But it's on you to provide a common interface to which the individual providers can listen to and reconcile. So we can call it a generic API from now on, and it's generic because it sits in the middle. There are the providers, there are the consumers, and in the middle you have this generic API which needs to be implemented by both of the parties. So let's do that. We can imagine that the platform had to communicate with providers and the consumers. They probably had to break their application because their API changed, so that's not very nice. But now we know better, and we have this API export with some standard public interface that they can use. And now, what do we do with the providers? We can maybe shove them together into the same virtual workspace so that they reconcile the same stuff. But there is, of course, a problem. Like they would see each other's work, so that's fun, and they would reconcile the same object, so that's not good. And as it turns out, the actual solution is to split and filter this virtual workspace by labels, and then constrain each provider to be able to access only objects of that particular label. Like if that object has my label as a provider, I can reconcile it. If it doesn't have that label, I don't even see it because it doesn't appear in that virtual workspace. So let's put it all together. So we have this generic provider on our platform, which is backed by the generic API. This is what we already seen, just to show that this is the actual generic API that we have agreed to use. Now, as a consumer, after you have bound to the export, you now need to, or somebody needs to label the objects of the resource that you have bound to. And there are a couple of ways this could go. One would be you as a consumer can choose which provider you want your resource, your object to be served by. Another option would be to let the platform define some sort of automation that can do the labeling by some criteria and choose for you, or something else. The point is that this really is a business logic of the platform, and it's platform owner's responsibility to deliver this sort of component that can, as a platform owner, only you know if your use cases are such that you need to choose providers for your consumers, or they can choose for themselves. And so having labeled an object, now it appears in one of the providers. If it's not labeled, it doesn't appear to any of them. If it gets labeled, it gets served by exactly one of the providers. And now, finally, on the provider side, so this green box is the provider's cluster. We are now outside of the platform. The provider reconciles the object that they have observed through the virtual workspace. One thing to note here is that the provider is free to use any API they want. It's their cluster after all. We are outside of platform. However, if this API differs from the one that is declared in the API export on the platform side, there needs to be some sort of conversion happening between those two types. And because it's the provider who knows the best their API and knows how to do this conversion between types, it's in their responsibility to do it. The good news is that there are existing tools that can help you with this. There is Crossplane or many other templating tools that can, go from one kind of object to another and convert between those two. And with that, we have an actual multi-provider service, which we will now see in a live demo.
So in this live demo, we have 3 kind clusters deployed and 1 KCP instance with 4 tenants in total, so 4 workspaces. The KCP workspace with the root services CA workspace that exports our generic API with the certificate, and then we have 1 consumer that will then instantiate the certificate. This could also come from an external kind cluster synchronized with kubebind, for example, or an operator that uses multi-cluster runtime to synchronize data between the workspace and the consumer cluster, or. And on the provider side, we have a kind cluster running with an operator, specifically here just cert manager, that then has the certificate custom resource from this provider specifically that is then templated with Crow to the certificate resource of cert manager, and API sync agent publishes this resource into its own provider workspace from where it's then used by the platform. So that's basically what's going to happen here. So what you see up in the browser, this is basically a dashboard. This will update with the live data in the clusters. What we are going to do now is that we instantiate the certificate. This is our generic API. This is just certificate example platform mesh IO. And this just says we want a certificate with the FQDM app internal corp. We are already in the consumer workspace. We're going to apply that. Yeah, that's the. Okay, okay, you didn't see it live. Maybe let's just. Okay, that's gone. Now you're going to create it again. So what you're seeing is that it's being created in the consumer workspace. It's synchronized through the virtual workspaces into the workspaces of the provider. The provider then instantiates and creates a certificate. This is a secret is then being synchronized back to our consumer. And if we now look at these secrets here, we can see a single secret that was created 21 seconds ago. And if we now extract that, we can see in the subject that this is exactly the FQDN that we are looking for. Okay. We can also see here in the related resource exactly the secret that we just inspected. No. This alone is all well and good, but that's not what we want. What we want is that we now get the certificate from another provider. So we are going to change the FQDN to app.corp.com. So that means our application is now being deployed externally. When we write this now, the resource broker, so the little operator that is implementing our business logic, will notice that the provider so far, the internal CA provider, does not satisfy the resource anymore. So what it's going to do is that it's going to write this into the workspace for the external CA provider, where it will then instantiate the new secret that will be synchronized back, and then all of the cleanup will happen. So let's write this. You can see that already the consumer cert changed, the external CA has gotten the generated the new certificate, and the secret has already been synced back into our consumer workspace. And if we look at the secret now, we can see, okay, there app.corp.com, this is exactly the subject that we have requested. So this is one API, the same resource now being served by another provider simply because we changed our order. And these two providers do not see each other's resources, which is exactly the separation of duty that we are looking for. So in summary, what are polymorphic APIs? They are an abstraction layer for services and resources. Why do we need polymorphic APIs? To realize that we can serve many consumers with one service by many providers with many flavors implemented by these providers. And this allows us to simplify operations on both sides of the API, because consumers can mock their services based on the APIs, and providers have a reduced set of standards that they can implement, and because they can implement different flavors, they can also do, for example, blind tests, where they then deploy, okay, we have a new version of our resource, of our service, so we deploy that alongside, and we gave it 10% of the requests, just like you do in web development. Yeah. And how can we implement polymorphic APIs with KCP as the service control plane that manages the service exports and data between them, and the Kubernetes resource model as our lingua franca. So that means our standard stays KRM and everything. So the virtual workspaces, the kind clusters, and the clusters that you're using, this is all Kube API. So you can talk with every single component with kubectl and all the tools that you are used to. Yeah. Finalizing, all of this is, of course, open source. It's all funded by public money, and we are very thankful for that, and we are always looking for more contributors and more people to get involved. We have the link for kcp.io and the link for Platform Mesh, and we have a nice little page, Get Involved, there, where all of our projects that we are working on and with are linked. Thank you for listening.
Thank you very much. Any questions?
So this operator you had in the middle that actually decide which provider is going to provide the service, is this one connected to the provider clusters through binding also? Is it also itself a consumer?
It's itself, the way it's implemented is that it itself is a consumer, yes, because the providers are exporting their specific API that looks like the generic API, and the platform is then importing this basically. And on the other side, the platform is exporting the generic API, which the consumer is importing, and then the broker is just looking into the consumer workspace. So the workspace here is then taking the resource and then validates which provider can serve this, and then writes it into the virtual workspace of the prospective provider. Exactly.
Okay, so even at this level, you're not sensitive to any change on the provider side. It's already kind of abstracted then.
Sorry?
So it means you're totally already abstracted, even in this operator, from any change in the provider.
Yeah.
Right, that's very cool. Thank you.
This is also open source. Resource Broker is in the Platform Mesh org on GitHub, so you can have a look and run it yourself. It's all there. Okay.
Ivra, no, any questions? No? All right. Last chance. All right. Thank you very much.
Thank you.
Thank you.